Hi, let's look at proven solutions to 5 test automation issues. My name is Wojciech and I've been doing software development for more than 15 years now, and over those 15 years what I've noticed was a pattern that over-the-wire test doubles such as API simulators and system simulators are a standard practice on some teams, like teams doing extreme programming, behavior-driven development or TDD, and on other teams the practice has been never heard of. So if you're one of those groups that have never heard of API simulation or system simulation, stay tuned and we'll talk about how that can help you with 5 test automation issues. We're going to be looking at a sample microservice architecture in this video. So we've got a web application that's connecting to a microservice, which in turn connects to 2 other microservices which connect to databases and hardware systems and third-party systems. Okay, so this is the production architecture. In development and testing, we're going to use simulators. So the mobile numbers web applications using a mobile numbers API simulator instead of the real mobile numbers microservice. The mobile numbers microservice is using mobile onboarding API simulator instead of the mobile onboarding microservice. And the mobile onboarding microservice, instead of connecting to real hardware, is connecting to a hardware simulator and an in-memory database. And then mobile number porting microservice, instead of connecting to a real third-party system, it's connecting to a third-party simulator. Okay, so this is the development and testing infrastructure with API and service simulators. The first issue that these simulators will help with is APIs and services that are not yet available. So we've got these automated tests that are testing our mobile numbers microservice, which is connecting to the mobile number porting microservice. Unfortunately, that team has not finished developing their API yet, so there's no responses coming back, so we can't finish our automated tests. What can we do in this scenario? Well, we can use mobile number porting API simulators instead of the real microservice and set up those simulators from the tests. So what that gives us, it gives us the possibility that our automated test will test the mobile numbers microservice, which sends a request to the simulator, not the real microservice, which will send the responses back to the mobile numbers microservice, and we can finish our automated testing without that real microservice being present. So I can show you a demo of that in a tool called Traffic Parrot. And let's have a look at our microservice. So first of all, this is the user interface of Traffic Parrot, which is the API and system simulation tool. And we've got our microservice that we will try and test now. I'm not writing automated tests, it would take a bit longer. I'm going to manually test this microservice to show you in principle what API simulators can do here for you. But what you can do is imagine, well, all of these things I'm doing manually here could be automated and automated tests. So I'm transferring a number to our mobile network, pressing send. Unfortunately, I'm getting an error. Why is that? Well, this microservice connects to another microservice, and that other microservice has not got that API that we need right now ready yet. Okay, and it's going to be ready in a month or 2 when the team finishes working on it. So what can we do to finish testing our test scenario here in a manual and then automated way? Well, we can use a simulator and we'll create it in Traffic Parrot. So I'm going to go to HTTP add and edit because this communication between these 2 microservices is done via HTTP. And what I know from the documentation is that the microservices communicate over this URL, so /port number, and it's a post request. The response would look like this, more or less. So this is what the teams have agreed before they started working in parallel. This is how the API would look like. So I can save this, and I've got my simulator mapping configured here, right? So right now, all I have to do is configure this Galaxy Mobile Network microservice for transferring numbers to the simulator. And I do that in the properties of this microservice. So I go to mobile numbers, application properties, and you can see the URL here is configured to point at Google Cloud functions, and that function is not available, unfortunately. So we're going to point it at traffic parrot which I've got running locally. Okay, so right now if I refresh the page and try to put that same number again, I should get a response. And yeah, there we go. So I got a response from that simulator written in Traffic Parrot or created in Traffic Parrot, and I was able to test the whole user scenario, and I can automate it right now in Selenium or any other framework that you choose to use. You can see this is what I'm expecting to see when I'm testing that transfer number functionality. So I know what to put in my assertions in the automated test because I've tested the whole user journey with a simulator, even though the real microservice was not available. So server doesn't exist, doesn't matter that much. We can run our automated tests anyway because we're using simulators. A case study from a team that I was working with, a department of 4 teams working on different microservices on a new platform, and those teams wanted to start working in parallel on different microservices. Unfortunately, the teams had dependencies, so Team A depended on Team B, which depended on Team C, which depended on Team E, which caused delays in testing, development, and generally time to market. So what they used was an API simulator tool to create those simulators for non-existing APIs, and this allowed them to parallelize teamwork and automate manual and exploratory testing without having to wait for the other teams to finish the work. And this significantly reduced the time to market and increased efficiency in development and testing. Since we're on the subject of API first development, so defining the API between 2 components before actually working on those components, there's an article we've published not that long ago that discusses the benefits of that practice and how to get started with it, and it also includes a spreadsheet which you can use to estimate how much you can gain from using this API first development practice. On top of what we've seen, which is parallelizing teamwork, using these simulators locally allowed us to do local development and testing. So instead of spinning up the whole stack of all those microservices, in our case there were only 3 with one web app. But imagine you have 10 or 40 microservices. Instead of having to spin up all of them locally to do local development and testing, you can spin 1 or 2 up and mock or simulate everything else. So simulators enable local development and testing. The second issue that you might see in automated testing is when slow or manual processing backend and third-party systems impede your automated testing. So you've got this mobile onboarding microservice that sends requests, in this example, to provisioning requests queue running on a message broker, let's say IBM MQ, and then some hardware devices consume those requests, do some slow background processing, and send response messages to the response queue provision confirmations, which then gets consumed by the mobile onboarding microservice again. So the challenge we have when we're automating this, the testing of this feature, is that when the hardware takes 10 seconds, 30 minutes, or sometimes 2 days to process those requests, we can't finish our automated tests. So what is the solution in this case? Well, you can use a hardware simulator that will respond in milliseconds. So your automated tests would set up this hardware simulator and then start testing the mobile onboarding microservice, which will send requests to the request queue, which get consumed by the hardware simulator and generates a response in milliseconds, sends a response back to the response queue, which gets consumed by the system under test, the microservice under test, and our automated tests are passing. So let me show you an example of that, how to create a simulator and simulate an IBM MQ response message. What I've got here is that user onboarding microservice, and I can say onboard a new user like that, and the user onboarding message has been sent to the request queue, right? But we're not getting any confirmations. You see no provision confirmations found. The reason for that is because that hardware system hasn't even consumed the message from that request queue. So we're gonna be waiting here for a long time before we see any confirmation messages back, and we'll be able to test this first of all manually, and then even start writing any automated tests for this microservice. So what we can do is use Traffic Parrot to simulate that hardware system, and we'll send those response messages in milliseconds back to our microservice. So we know from the documentation of those systems and from the logs in where we see in the staging environment the real messages being sent to and from the IBM MQ systems is that the request queue name is provision request. This is the response queue name, and the response would look more or less something like this. So we're gonna go to traffic parrot, to JMS, and the same pattern here, request and response. We're gonna say, hey traffic parrot, whenever you see a request on this queue name, send a response to this queue, and this is what the response body should look like. Save that. There we go. We can view it here. So traffic parrot is going to consume requests from this queue and produce responses into this queue with this body. And we can tell traffic parrot to connect to the same broker, IBM MQ broker, that this user onboarding microservice is connected to, which is my local MQ9. And see what happens in the user onboarding microservice. And you can see we've already got one confirmation message here. Why is that? Well, that message, the request message to onboard the user, was sitting on IBM MQ, the request queue, and traffic parrot, when we turned it on, picked up that message and created the response message immediately. So I can send a few other ones in here, and you can see traffic parrot is successfully simulating the hardware device here. The backend processing or third-party processing is very slow. We use simulators that respond in milliseconds, and we can continue automating our tests. A case study from real world, we've been working with this customer that was integrating with a government entity, and the processing on their side was done manually per test case, and it would take 30 minutes to even sometimes 2 days. This company used IBM MQ simulators to simulate the government systems, and this allowed them to unblock the automated testing of manual regression tests, and that improved the test automation process and increased the efficiency of regression testing. The third issue that you'll see when writing automated tests is test data setup issues. So we've got an automated test that ports a number to our network, and it sends a request and it burns the test data. And by that we mean the state in the database changes and the state in the third-party systems change. So you can't send the same request twice to port the same number twice to our network. It just doesn't make sense. And the response is not repeatable as well. So the automated test would have to send different numbers for every request if you're connecting to the real third-party system. So what can we do with that? Again, we use simulators here and set them up from the automated tests, and they pretend to be the mobile number porting API in this case, and we don't have to deal with its state in the database or in the third-party system. We're just testing that the mobile numbers microservice is working as we expect it to. We've been working with this company that was doing manual test data configuration in a third-party system, and the solution here was to create an API simulator for a sample basic use case, and it took them only 2 hours to do it, whereas the manual test data configuration was taking sometimes weeks in the third-party system. That allowed them to continue testing without having to refresh the test data. And on top of that, over the next several weeks, they've spent around 20 hours adding more responses to those simulators to cover both happy path scenarios and error cases. And overall, it improved their test data management and increased their test coverage. Another case study is where we were working with this company that had a test environment that was needed for the automated tests. Unfortunately, when they ordered the hardware devices that were required to be in the test environment, they would have had to wait at least 6 months for them to arrive. So what they decided to do is create a device software simulator instead of waiting for those real hardware devices, and spend 2 weeks of two developers' time to create that basic simulator. So what that allowed them to do is create automated tests without waiting for new devices in the test environment, and improve general environment availability. So imagine right now you're waiting for 2 weeks instead of 6 or more months for a test environment to be available. So a faster creation time of that automated tests. The fourth issue you'll see when you're dealing with automated tests is that sometimes setting up hypothetical situations or error scenarios can be quite challenging. So for example, imagine you have to set up in third-party or backend systems things like a response with a very high price, a response with many accounts, a response with a very long username, a response with different types of characters in it, or a response with different empty fields, etc., etc. So in some systems it might be okay to set those things up. In some systems it might be hard to set the test data up. With simulators, it's quite straightforward. You just change your simulator response to whatever you want it to be. And then when it comes to exceptional cases and protocol errors such as 503 service unavailable, 401 unauthorized, and different types of errors for different types of protocols like IBMQ, gRPC, Kafka, RabbitMQ, they'll all have different protocol errors. On top of that, you can have slow responses, timeout, dribbling responses, and dropped connections. How do you simulate that in a real environment with real systems? It's close to impossible for protocol level errors. And it's really actually important to mind that when you're testing your microservice architectures, because microservices rely heavily on network connections. With simulators, it's quite straightforward. We've been working with this client that was configuring error responses in a third-party system, but it's quite difficult to configure those error responses in the third-party system. And unfortunately, those were expected error scenarios, so they had to actually be covered in the automated tests. So what they've used is an API simulator to simulate the third-party system and configured all of those 23 expected error scenarios there. So this improved their testing of error scenarios and increased the coverage in automated testing. Let me show you an example of creating error scenarios in Traffic Parrot. So do you remember our transfer number microservice? What we're going to do is go back to HTTP add and edit, and I'll duplicate this mapping, and I'll have two scenarios here. The first one is whenever we send a request that contains in the body the number 123, we're going to return an error actually. And an error response should look like this, because we know we've discussed this with the other team that was developing this microservice, and we know that even though it doesn't exist, this is what an error is supposed to look like. And we're going to say that this is priority 1, so that whenever Traffic Parrot sees more than one mapping in a simulator that matches a given request, choose this one actually. And then what we're going to say is we're going to keep the other one as it was. So anything else to port number, just return a success. Okay. So right now what I can do is test the mobile number and say 123, 123, and this is actually it's going to return the error response. So Traffic Parrot is going to return the error response to this microservice, which should render an error to the user here. And you can see, unfortunately, what this does is it returns a successful response. That's a problem. So we need to talk to our developers and product owners and tell them, hey, even though the response from the service is coming back as an error, we're rendering it here and showing it to the user as a success. And how do we know that? Well, we can, for example, open up Postman and test that the response from that simulator is actually an error. So I'm going to send a request to the simulator. We can see that the simulator is actually returning an error when we send the mobile number as 123, 123. And a success when we send a different mobile number. But our application here, even though it's connected to that simulator, is interpreting that error response as a success. So we need to fix that issue in our transfer number feature in this microservice. So we found a bug, even though that real microservice is not ready yet. And we were able to do that by using a hypothetical situation simulator using Traffic Parrot. Another case we can simulate is slow responses. So in Traffic Parrot, if you want to make this successful response very slow, what we can say is just dribble the byte for 1 second each. And now if I refresh the page and try to port the number, I'm not getting any response back here. That is because Traffic Parrot is dribbling those bytes back to the microservice very slowly, simulating a slow connection. So what I would expect to see here is probably like a spinning bar saying, well, we're waiting for a response or something like that. Right now, the user probably will press send multiple times because there's no feedback back to the user. So this allows us to test protocol level issues with Traffic Parrots and simulators that would be otherwise very hard to test with real systems, and are important to test because microservices rely heavily on network connections. The fifth issue you might see when doing automated tests that rely on third-party APIs or services is that those services and APIs might be restricted. For example, throttling, rate limiting, or numbers of parallel connections. An example here is when we were working with a company where their API they were integrating with had a limit where you could only send 3 requests per second during a span of 5 seconds. And how do you test that scenario if you can't test it in the test environments? Because the test environments do not replicate this behavior. It's only the production environment that has this feature embedded. Well, you create a simulator that simulates this third-party API behavior, and you test on your side, does my application actually behave the way it's supposed to in this scenario? Does it send only 3 hits per second during a span of 5 seconds maximum? Another thing you'll notice sometimes is that third-party test environments have got rate limits on how many requests you can send to them, and the production environments don't. So how can you run enough automated tests or even performance automated tests against that kind of environment? Well, looks like in some cases not many. So what you can use is simulators to simulate that API or service, and that way you can run as many requests as you want. So stepping back for a second, all I'm trying to say here is along your test automation journey, what you'll find is you'll hit some of these roadblocks like APIs or services not available, slow manual processes in the backend or third-party systems. Just keep in mind that using API and service simulators might help you automate further if you hit this bottleneck. I hope you can also see that it should be easy to get started. You can just start with one API on one service and one automated test. You don't have to boil the whole ocean. So if you're a director or a head of QA and you've got this OKR KPI that talks about automated team testing, just review this presentation with your team and prepare a plan on how you could reach out maybe to us or use API simulators to help you with your automating testing journey. And if you're a technical person such as an architect, developer or tester, just talk to your team and management to get time to look into this practice. Thank you so much for watching. If you'd like to learn more, feel free to follow me on LinkedIn. And if you'd like to try Traffic Parrot and evaluate it to see if it can fit your project's needs, please go to trafficparrot.com and request the trial. Thank you so much for watching, and until the next time.